With such a tough final question, 9 out of 10 kids just guess. How should you solve a problem like this? The question asks you to cleverly find the perimeter and tells you that all the angles are right angles. Looking at such an irregular shape and being asked to find the perimeter, many kids get confused right away and don't know how to solve it. So what should you do? Today, Teacher Dong will teach everyone a trick, the marking method, to easily solve it. What is the marking method? Take a look, for example, at a rectangle. If I start from any vertex of the rectangle as the origin, what do you notice when you walk around it? Starting from this origin point, if I first go up, then move to the right, then go down and finally turn left, I will end up right back at the same origin after making a full loop. Don't you think? Now, according to the properties of a rectangle's perimeter, the opposite sides are two equal line segments. So the segment going up on the left is equal to the segment going down, right? And this segment going to the left is equal to the segment going to the right. Let's write this out. So we've discovered this kind of pattern. Based on this pattern, let's apply it to other cases and take a look at this special shape. Let's look again. Suppose we take one of the vertices as the origin and start from there to walk around the shape. Let's see which directions we go in. Look, starting from here, first we go up, then right, then down, then left, then down again, then right, up, right, down, left, up, and finally left again, returning to the original point. After making a full circle like this, the sum of all the edge lengths going up should be equal to the sum of the edge lengths going down, right? And the sum of the leftward edges must also equal the sum of the rightward edges. Now, how do we find the lengths of the edges? I noticed that there are quite a few edges here whose lengths we don't know, right? Look, we don't know the length of this downward edge, and we also don't know the length of that downward edge over here. The downward edges aren't all given, but can we find the upward edges? Which edges are the upward ones? Look, first, this edge is going up, right? Here, there's an 8. Come on, let's keep going up and down. Here is also an upward edge, and this one is 5. Are there any others? This is also an upward edge. If we add up these 3 upward edges, can we find the total length of all the upward edges? Let's write it down. The sum of the upward edges is just the sum of these 3 parts, 8 plus 5 plus 3, which equals 16. No problem, right? So the total length of the upward edges is 16. Doesn't that mean the total length of the downward edges must also be 16? It must also equal the sum of the downward edges, so there's no need to calculate it again. We've finished looking at up and down. Now let's look at left and right. We don't know the rightward edges here, and we don't know them here either. But can we find the leftward edges? Try to find which ones are going to the left. Look, this edge goes to the left. That's 4. Are there any others going to the left? This edge goes to the left, it's 2. And this edge goes to the left, it's 13. All right, so which ones do we add up for the total length of the leftward edges? We need to add 4 plus 2 plus 13. So what's the total? Let's add up these 3 numbers and we get 19, right? Now, the total length of the leftward edges must also be equal to the total length of the rightward edges, right? No problem, right? All right, we've now figured out the total lengths for up, down, left, and right. So how do you think we should find the perimeter? We just add these 2 numbers together, 16 plus 19, and then what? Then multiply by 2. So what's the final answer? Isn't it 70? Easy to solve. Did you get it? Follow Teacher Dong to learn more great methods.